The sun's been shining constantly for literally billions of years, and fortunately for us, it's going to do so for billions of years to come. But how does it do it? If it were burning like coal, it would run out of fuel in just a few thousand years. It was Albert Einstein who gave the clue when in 1905 he suggested that mass and energy were different forms of the same thing. You've probably heard of his famous formula E equals mc squared. This means that you can turn a little bit of mass into a huge amount of energy. It was a British astronomer, Arthur Eddington, who realised in the 1920s that this was the key to the sun's great power. But it took some time to work out just what happens inside the sun. We now know that at its centre, temperatures are so high that particles crash together and in the process release energy. The odd thing is that the amount of actual heat released within, say, a cubic metre of the sun is really quite small, about the same as a typical compost heap. But while a compost heap quickly cools down, the sun is so huge and the heat is released over such a long time that overall it just keeps on giving. If only we could find a way to release energy in the same way, that's nuclear fusion, on Earth. A lot of effort is going into finding a way, but the possibility of having a convenient power supply into which you can put your rubbish and get huge amounts of power from it, as in the film Back to the Future, is a long way off. The sun is a very stable and reliable star, but what about those sunspots which appear on its surface? Their numbers come and go, and every 11 years or so there are plenty, a time called solar maximum, then a few years later there are hardly any. You might think that lots of sunspots would mean that the sun would be a bit dimmer, but actually at solar maximum it's very slightly hotter than when there are no sunspots. Solar maximum is also a good time for the northern lights, which are caused by streams of particles from the sun, but sometimes these can even happen at solar minimum. Astronomers sometimes describe the sun as a typical star, and in some ways this is true. It's about halfway in brightness between the very biggest and brightest stars, which are called blue giants, and the smallest and dimmest stars, red dwarfs. Actually, there are very many more red dwarfs than there are large stars, so in fact the sun is really quite unusual. It's also a single star, whereas many stars like it are multiple stars, with two or even more stars going round each other. It might be fun to have two suns in the sky, but any planets going around the pair would probably have extreme swings of temperature. So let's hear it for the good old sun, which just keeps on going and provides us with almost all our heat and power.